Hi, math enthusiast. I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. See you all in e-DEOlogy community and get this beautiful e-DEOlogy fun badge and be a member according to your interest as a bronze member, a silver member, or a gold member. We love to see you in e-DEOlogy community. Hi everyone. Today we're going to study graphs of quadratic functions given the standard form of a quadratic function. Let us now identify quadratic function in standard form. The standard form of a quadratic function is f of x equals a times the quantity square of x minus h, then plus k. We know that the graph of a quadratic function is a parabola. In the standard form, we can see here the h and the k, and that is exactly the vertex of the parabola. Also, this a gives a very special idea. The parabola opens upward when this a is positive, or the parabola opens downward when this a is negative. Let's have an example. Sketch the graph of the function f of x equals negative 3 times the quantity square of x plus 2 plus 4 and find the following. Letter A, vertex. B, axis of symmetry. C, range. D, maximum or minimum value. E, decreasing interval. And F, increasing interval. From the standard form of the quadratic function, as written here, we can collect the vertex immediately. However, let us make sure that the given function must be in the standard form, or we may rewrite the given function into the same way with our standard form, and it will be like this. We are going to copy exactly the same except in this plus 2. Since the standard form is written minus h, we are going to rewrite this plus 2 into negative of negative 2. And the rest of the function will be same. And from here, we're going to collect now the vertex or the hk values. So this negative 2 is the h and the positive 4 is the k. Therefore, the vertex has the ordered pair negative 2, 4. And then this negative 3 is the a. And since our a here is negative, it means the parabola opens downward. So let us copy the vertex opposite this letter a, and we will take note that the parabola opens downward here. Then let us clear the right side of the screen. Since the vertex is known, and we know that the parabola opens downward, we can now draw the parabola. So we have a parabola here that opens downward, and the vertex is the highest point. That is now the point -2, 4. Now letter B, for the axis of symmetry, it is the vertical line that passes through the vertex. And our formula is x equals h. And this h is the x coordinate of the vertex itself. So we will just substitute the value. So here the h becomes -2. Therefore, the axis of symmetry is x equals -2. For the range, we have the formula, the -infinity, comma, k, and we use the square bracket. This k is the y coordinate of the vertex. So we will just substitute the k. It becomes 4. The range now is -infinity. Of course, we use the parentheses, then comma, 4, and the square bracket. Now for letter D, maximum or minimum value. The parabola opens downward, so we don't have a minimum value because the graph of parabola goes down continuously. So we have a maximum value here. And that value is equal to the k itself, and this k is that y coordinate of the vertex. So we have k equals 4. So the maximum value is 4. Now letter E, decreasing interval. With respect to the axis of symmetry, the right side of the parabola is our decreasing interval. Do you remember? We're going to read the graph from left to right, and when it is going down, that is the decreasing interval. So this side here is the decreasing interval, and our formula is the square bracket h, comma, positive infinity, parenthesis. And this h we will now change by the x coordinate of the vertex. So the decreasing interval h becomes -2. So this is now our interval notation for the decreasing interval. For the increasing interval, that is the left side of our parabola. You see here, if you read the graph from left to right, so that is the increasing interval. And we have the formula for that. That is the parenthesis, -infinity, comma, h, and square bracket. We will just substitute the h value with our x coordinate of the vertex. So our answer is the -infinity up to -2. We use the square bracket here and also the parenthesis because we know every time there is infinity, always parenthesis is used. So we are now complete with our answers. Hi everyone. Today we're going to study graphs of quadratic functions. In particular, we will study the general form of quadratic functions. A quadratic function is a function of degree 2. The general form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. By the way, when we say degree 2, the highest power that we can see in the function is square. Let's have examples. This is the first example. F of x equals x squared plus 4x plus 3. With regard to the general form, we can collect the values of a, b, and c respectively for the given function. So in here, the a is 1, that is the coefficient of x squared. The b is 4, and the c is 3. Another example is f of x equals negative 2x squared minus 4x plus 8. Also, the a equals negative 2, the b is negative 4, and the c is positive 8. This is now a fact that the graph of a quadratic function is a parabola. These are pictures of parabola. One is opening up, another parabola is opening down. Let's begin with a parabola that opens upward. The general form of the quadratic function is here. The f of x equals ax squared plus bx plus c. The properties are here. Number 1, a is greater than 0. It means the a, which is the coefficient of the x squared, is positive. We have the example a while ago. In here, the a is positive 1, and we can say that this function has a parabola that opens upward. Property number 2 is the vertex. This is the vertex, the lowest point of the parabola that opens upward. And the ordered pair of the vertex is hk. The formula for h equals negative b over 2a. Take note, the b here is the coefficient of x, while the a is the coefficient of the x squared. And the k value equals f of h. Property number 3, the axis of symmetry. A parabola has symmetry with respect to a line, and this line is called the axis of symmetry. We can see this is a dotted red line in here. And the formula for the axis of symmetry is x equals h. Property number 4. The domain is all real numbers, and we can write it in the interval notation to be negative infinity, comma, infinity. For the range, these are the values for the y. So this is square bracket k, comma, infinity. Number 6, the minimum value, which is k, equals f of h, or we can simply copy the value that we have from the vertex. We can write here. Number 7, decreasing interval. A parabola has a decreasing interval, and later on we will have increasing interval. If you're going to read the parabola from left going right, the decreasing interval is the left side of this parabola with respect to the line of symmetry. So we can write the interval to be negative infinity, comma, h. And we use the square bracket. Likewise, for the increasing interval, this is the graph, the right side of the parabola, that is the increasing interval. It is going up. And the interval notation for that is square bracket h, comma, infinity. Now let us have the parabola that opens downward. The vertex is now on top. And let's begin with our property number 1. A is less than 0. It means A is negative. A while ago, we have an example f of x equals negative 2x squared minus 4x plus 8. We can see here that the value a, the coefficient of x squared, is negative 2. We can say immediately that the graph of this function is a parabola that opens downward. Let's go to property numbers 2, 3, 4. These three properties are the same properties of the parabola that opens upward a while ago. The vertex is hk, and we can compute the h equals negative b over 2a. Again, b is the coefficient of x, and the a is the coefficient of x squared. Also, the k equals f of h. Property number 3, the axis of symmetry. This is the axis. And the equation is x equals h. Property number 4, the domain is all real numbers, and the interval notation is negative infinity up to positive infinity. Property number 5 is the range, the values for y. So with respect to the y-axis, it starts with negative infinity, and the highest is the k value, and we use the square bracket. Number 6, the maximum value is k, and we can simply copy the value of k in the vertex. We can write here. Number 7, decreasing interval. So the interval from which the graph is going down. So our parabola is opening downward. So the right side from here, it is decreasing. So our interval notation, square bracket, h, comma, positive infinity. For number 8, the increasing interval is the left side of the parabola. It is going up. So our interval notation for the increasing interval is negative infinity, comma, h, and we use the square bracket. Let's have an example. Sketch the quadratic function f of x equals x squared plus 4x plus 3, and find the following: a, vertex, b, axis of symmetry, c, range, d, maximum or minimum value, E, decreasing interval, F, increasing interval. First, let us write the general form of the quadratic function. F of x equals ax squared plus bx plus c. And then, let us collect the corresponding values for a, b, and c in the given function. So a equals 1, b equals 4, and c equals 3. Please note that the a is positive, and we can say now that this parabola opens upward. Now let us start calculating the vertex. We have the formula for the vertex. For the h is equal to negative b over 2a. Let us substitute the values. For the b, it is 4, and for the a, it is 1. So let us simplify this negative of 4 over 2 times 1, and we have the answer negative 2. This is the h. Now for the k, what we will do, we will use this value of h in our original function. It means I'm going to copy the same function down here, but every time there is an x, I will change that by the h value, which is negative 2. So we have the x squared becomes the square of negative 2 plus 4x is now 4 times negative 2 plus 3. We simply copy here. Then we simplify. The square of negative 2 is positive 4 plus 4 times negative 2 is negative 8, and then plus 3. Simplifying this, we have the answer k equals negative 1. It means we will write the vertex as an ordered pair. It is negative 2, negative 1. We will copy this value opposite letter A in here. So we have now the answer for the vertex. Since we have the vertex, we can draw now the parabola. This is now our parabola, and the parabola opens up. Let us compute now for the axis of symmetry. This line here. We have the formula, and this h is simply the negative 2. So we will just replace this h by the negative 2. So we have now x equals negative 2. And this is now the axis of symmetry. For the range, the formula is square bracket k, comma, infinity. This k is the y coordinate of the vertex. So we will just change the k by negative 1. So our range is square bracket negative 1, positive infinity, close parenthesis. So we are done with the range. Now letter D, maximum or minimum value. Since the parabola is opening upward, we have a minimum value. There is no maximum value because the parabola is going up continuously. So the minimum value is that k equals the f of h. No need to compute for this. The k value we can simply copy from the y coordinate of the vertex. So k equals negative 1. So we are done with letter D. Now for letter E, let's have the decreasing interval. The parabola is opening upward. The left side of the graph with respect to the symmetry is our decreasing interval. And our interval notation is negative infinity up to h. So we will just change this h by our x coordinate of the vertex. So we have negative infinity, comma, negative 2, square bracket. So we are done with decreasing interval. Going to increasing interval, that is now the right side of our parabola with respect to the line of symmetry. And the interval notation is square bracket h, comma, infinity, parenthesis. Now this h, again we will change by the value that is negative 2. So it becomes square bracket negative 2, comma, infinity, parenthesis. So this is now the answers for our example. Hi everyone. Today we're going to study zeros of a polynomial. Let us define zeros of a polynomial. The number a is said to be a zero of the function, which is a polynomial denoted by p of x, or a solution of the equation p of x equals 0 if p of a equals 0. Here are the steps in finding zeros of a polynomial. Given a polynomial function p of x, step 1 is make p of x equals 0. Step 2, solve for x. Let's have an example. Find the zeros and minimum or maximum value of the quadratic function f of x equals x squared plus 2x minus 8. Step 1, make f of x equals 0. First, let us copy our function down here. Then, we will change this f of x into 0. So we have now 0 equals x squared plus 2x minus 8. Step 2, solve for x. Let us interchange the polynomial, the x squared plus 2x minus 8, and then the 0 will be on the right side. Solving for x, let us use factoring. Please review our video regarding factoring of trinomial. So when we factor our trinomial here, we have two factors which are both binomials. So we have x plus 4 times the quantity x minus 2 equals 0. And then for each factor here, we will equate to 0. So we have this x plus 4 equals 0. Also this x minus 2 equals 0. And we will solve for x in both equations. So here, the positive 4 is transposed on the right side. The sign will be changed. So we have x equals negative 4. And the other equation, the negative 2, we will transpose on the right side. The negative becomes positive. So we have x equals positive 2. So we have the two values of x, and these are what we call the zeros of the polynomial. So we say that the zeros of the function are this negative 4 and positive 2. Let us note that the zeros of the polynomial function are the x-intercepts of the graph. This is the graph of our function. So you see here, with respect to our x-axis, the graph touches our x-axis at the point negative 4 and positive 2. Now let us find the minimum or maximum value. First, let us copy our function and take note that our a equals 1. We know that a is the coefficient of our x squared. And this one is a positive value. So it means we have a parabola here that opens upward. So this is our parabola that opens upward. It means to say we are looking at a minimum value, and this is the lowest value. So let us complete writing the a, b, c. For the b, we have 2, and this 2 is the coefficient of x, and c is the constant, which is the negative 8. So let us find the minimum value. When we find the minimum value, we are looking at the vertex itself, and that is the lowest point of our parabola. To compute for the minimum value, let's begin with our axis of symmetry. Remember, this axis of symmetry is a line. It is a vertical line that passes through the vertex. So this is our axis of symmetry, and the equation is x equals negative b over 2a. These a and b are the coefficients of x squared and x respectively. Substituting the values, we have now this negative of b, and the b is positive 2 over 2 times a, and the a is now changed into 1. Simplifying this, we have now x equals negative 1. This is the equation of the axis of symmetry. And this negative 1 value is the same value of the abscissa of our vertex. So in here, the point negative 1 comma y, that is the coordinates of our vertex. Later, we will get the value of y. Now, let us compute for the minimum value by evaluating this f of h. This h is the abscissa of our vertex. So we have f of negative 1. It means to say we're going to evaluate our function using this value negative 1. So every time we see an x here, we will change by negative 1. So here we go. So the x squared becomes negative 1 squared plus the 2x now becomes 2 times negative 1. And we simply copy the constant, negative 8. Simplifying further, this square of negative 1 is positive 1. 2 times negative 1 is negative 2. And the constant negative 8 is copied down here. Simplifying this, we have now negative 9. And this is our answer. This is the minimum value. Now, this negative 9 value is the same value for the y here. And we can substitute it now. So the vertex is negative 1, negative 9. And this is our final answer. I hope you learned something from this video. See you again next time.